Hello friends, I welcome you in lecture number 3 on applications of integration. In previous two lectures, we have discussed how to obtain areas using definite integrals. From this lecture onwards, we will see how we can use definite integrals to obtain volume of solids of revolution. We will discuss the meaning of solid of revolution also. There are different methods for calculating volume of solid of revolution. We will discuss them one by one. In this lecture, we will focus on disk method for calculating the volume of solid of revolution. So before going for disk method, we just recall the formula for the volume of a cylinder which we are familiar with. Suppose we consider a cylinder with area of base. Suppose this is the base of the cylinder and it is a circle. Suppose radius is r, then this is going to be base area, and this distance between two base areas is the height of the cylinder. So we know that volume V of cylinder is given by base area, which is area of the circle with radius r, and it is pi r square, times height of the cylinder, which is h. So this is going to be pi r square h. So we will remember this formula. We will require this formula whenever we have cylindrical shape or cylindrical cylinder. So we will remember this formula which we are familiar with. Now first we understand what is meaning of solid of revolution. So suppose we consider some region in the xy plane. For example, suppose we consider the region in the xy plane which is bounded by some function. Suppose this is the graph of y equal to fx. Suppose this line is x equal to a, and this line is x equal to b. So we consider the plane region bounded by this lines x equal to a, x equal to b, and between the graph of y equal to fx and x axis. So we consider this plane region bounded by y equal to fx and the lines x equal to a, x equal to b, and x axis. Now suppose we consider rotation of this plane region about x axis. So what we will obtain, that we can visualize in three-dimensional space. Here we are working in two-dimensional plane, but we can visualize that what we will have or what will be the look for solid which we will obtain by rotating this plane region around the x axis. So to obtain the rough sketch of the solid which we will obtain by rotating this plane region about x axis, we can sketch in this way. We first keep in mind that we are rotating this plane region about x axis. So first we take the mirror image of this y equal to fx about x axis. So this is the y equal to fx, and if we take mirror image of this about x axis, then we may have this type of picture, and then we can join these two. Let me be precise how it will look if we consider its reflection, or suppose we have to consider this much distance below x axis, and because we are taking mirror image, we must have this type of shape. Let me clear it. It may look like this. If we take its mirror image about x axis, then it will look like this, and we will have this type of shape. So this is the rough sketch of this solid which we will obtain by rotating this plane region around x-axis. X-axis is called the axis of rotation. So this is in two-dimensional. I am sketching in two-dimensional plane, but we can imagine that the solid which we will generate by revolving this plane region will look like this. So this solid is called solid of revolution. Solid which we have obtained by revolving this plane region about x-axis. So we are interested in the volume of this solid, how to obtain the volume of this solid using integration. So for that we consider a cross section of this solid perpendicular to its axis of rotation. Here axis of rotation is x-axis. So we take a cross section, we cut this solid by the plane which is perpendicular to x-axis. So if we cut this solid by the plane which is perpendicular to x-axis, then the cross section will be a circular disc like this. This is also we are visualizing in three-dimensional space, but we will obtain a disc in this way. I repeat, if we take the cross section of a solid perpendicular to its axis of rotation, or we slice, we are taking a cut perpendicular to axis of rotation by a plane. So if we cut this along this line perpendicular to x-axis, then we will obtain this type of circular disc. Now this circular disc will have radius, which is the distance of this graph from axis of rotation. Radius of this circular disc will be the distance between the graph of fx up to axis of rotation. So this distance is going to be radius for that circular disc, which is the cross section of a solid perpendicular to x-axis. So this radius is going to be equal to y. So this is the radius of the circular disc, which is the cross section of a solid perpendicular to axis of rotation. Now we know that because we are having a circular disc, its volume is going to be a base area. So that is area of the circle with radius y, which is pi times y square, because y is the radius, into height or thickness of the disc. So suppose thickness of the disc is denoted by delta x, then here we have to multiply by height or thickness of the circular disc, which is delta x. So this is the volume of one circular disc, which is the cross section perpendicular to x-axis of this solid. Now suppose we are interested in the volume of a solid, then we are taking different cross sections. Suppose we consider another cross section, we obtain another circular disc. So we obtain volume of this circular disc. So in this way we can partition this solid and we obtain this different discs, which are the cross sections perpendicular to x-axis. So by calculating volume of this circular disc and taking their summation, we can obtain the volume of solid of revolution. So suppose the number of cross sections is denoted by n, and if we take larger and larger number of cross sections, that is if we approach n tending to infinity, then we will have the formula for volume using definite integral, we can integrate this with respect to x from the limits of x. Here x is starting from a and ending up to a. So at this point x is a, at this point x is b. So we have this formula, x equal to a to b pi y square dx. So this method is known as disk method because we are using volume of disk to obtain the volume of solid of revolution. So again I repeat, suppose we generate a solid of revolution by rotating this plane region around the x-axis. So we will obtain this type of solid of revolution. Now to obtain the volume of this solid of revolution, we consider a cross section perpendicular to the axis of rotation. If we cut this solid perpendicular to x-axis, then we will obtain a disk which is in circular shape, or we obtain a circular disk. Now radius of that circular disk is the distance between axis of rotation and the graph of y equal to fx. So this distance, which is y, will be the radius of this circular disk, and suppose thickness of this circular disk is delta x, then volume of this circular disk is base area, which is pi into y square times delta x. And we cut in this way, we consider infinite number of cross sections. Suppose number of cross sections is denoted by n. So as we approach n tending to infinity, we can find out the volume of solid of revolution by taking sum of volumes of circular disks. So in that way we can obtain the formula for volume of solid of revolution, which is generated by revolving this plane region R around the x-axis. So this x-axis is known as the axis of rotation. So it is not necessary that we revolve about x-axis only. We can revolve about y-axis, and in that case, suppose we consider this type of region. Suppose we are revolving about y-axis. Suppose we have this type of region, plane region. So if we have this type of plane region, we can rotate about y-axis. So in that case y-axis will be the axis of rotation. So in that case the solid will look like this. Okay, we can just have the rough sketch of the solid. So we may have this, we can copy this, we take mirror image of this. So we go up to this and then we have this. Okay, we are taking mirror image of this to find out the solid, rough sketch of the solid of revolution. So our solid will look like this. If we rotate this plane region around y-axis, then the solid of revolution which we will obtain will look like this. So here axis of rotation is y-axis. So to obtain the volume of this solid which is generated, we consider a cross section perpendicular to x-axis, y-axis, not x-axis. Here axis of rotation is y-axis. So we take a cross section perpendicular to y-axis, and we will obtain a circular disc. We have to go up to this, our circular disc or cross section perpendicular to y-axis will look like this. Just a minute, this is just a rough sketch, but I will try to sketch so that it will look like a disc. And suppose this is the thickness or height of the disc. So when we cut or we slice perpendicular to y-axis, we will obtain this cross section which is a disc. Now suppose we are interested in the radius of this disc, then we will focus on the distance between axis of rotation and this curve. So we have to go from this point to this point. So suppose this is the equation of this is x equal to fy, then the radius of circular disc will be equal to x equal to fy, or the radius will be x. X is the radius of the circular disc which we have obtained by taking cross section perpendicular to y-axis, and suppose thickness of the disc is delta y. Okay, we are talking about this. This is the thickness of the disc and that we denote by delta y. So the volume of this disc is going to be pi times x square times height or thickness, which is delta y. So now we continue this process. We are taking cross sections perpendicular to y-axis, and by taking infinite number of cross sections we obtain the formula for volume of solid of revolution, and we obtain that this is from y equal to say c to d, and here x is a function of y, so we will substitute x equal to f of y, and we will have function of y which we can easily integrate with respect to y. So it is not necessary that axis of rotation is x-axis or y-axis. It can be any other line in the plane also. So first we will discuss the problems in which the axis of rotation is either x-axis or y-axis. If axis of rotation is x-axis, this will be the formula for volume of solid of revolution, volume equal to pi times y square dx, and if axis of rotation is y-axis, volume of solid will be given by v equal to pi times x square dy. So if you have understood this, we can easily discuss one question which was asked in GTU Summer 2019 as well as Winter 2020 exam. So we understand this question. The region between the curve y equal to square root of x, 0 less than or equal to x less than or equal to 4, and the x-axis is revolved about the x-axis to generate a solid. Find its volume. So first we sketch the region which is given and which we want to rotate about x-axis. So we just have a rough sketch of the region. Suppose this is xy plane. Now what is given curve is y equal to square root of x, and between x equal to 0 and 4 and x-axis. So we know that y equal to square root of x is nothing but parabola whose vertex is at origin. So here I have y square equal to x, and I know the shape of y square equal to x. It will look like this. It is a parabola. So this is, let me sketch properly. This is y equal to square root of x. Suppose this distance is 4. So we have x equal to 4 here, x equal to 0. This is x-axis. It is the axis of rotation, and this is y-axis. So now we are asked to find out the volume of a solid when this plane region, which I have shaded by these lines, is rotated about x-axis. So here axis of rotation is x-axis, and first we try to consider the rough sketch of the three-dimensional solid which we will obtain by rotating this region about x-axis. You can easily imagine or sketch the rough sketch of solid which we will obtain by rotating this plane region about x-axis. Axis of rotation is x-axis. So we are rotating this plane region bounded by y equal to square root of x, and x axis about the x axis. So to sketch that solid, we will just consider the solid between 0 and 4. I will take this same distance. Now what will be the look of the solid which we will obtain by rotating this plane region about x-axis? So that we can obtain by just taking the mirror image of this y equal to square root of x. Mirror image of y equal to square root of x. Suppose I want to sketch the mirror image of y equal to square root of x, then it will look like this. Okay, we are just considering the mirror image of y equal to square root of x about x-axis. So the solid of revolution which we will obtain by generating this plane region will look like this. This is the solid of revolution which we will obtain in 3-dimensional space by rotating this plane region around x-axis. Now it is simple. We consider a cross section perpendicular to x-axis. Suppose we cut this solid by a plane perpendicular to x-axis, then the cross section will be a disc. Let me try to sketch properly. So the cross section is going to be a disc with some radius and some thickness. So radius is going to be distance between this axis of revolution and this curve. So this is going to be radius. Radius is the distance between x-axis, which is axis of rotation, and this point, and this distance is y. And we have to consider this type of cross section starting from x equal to 0 to x equal to 4, and it is clear that the radius of this circular disc is y and thickness is delta x. So by disc method, the volume of this solid which is generated by revolving a plane region, volume of solid of revolution, this is going to be integral from x equal to 0 to 4, area, base area, which is pi into y square, times height, which is delta x, that we obtain as dx by taking all possible cross sections which are circular disc, and this is going to be 0 to 4. Now value of y is distance between these two. Here upper curve is under root x and here value of y is 0. So radius is y equal to square root of x. So that we substitute here square root of x whole square, and this is easy to integrate. We obtain 0 to 4 pi times x dx, and this is equal to pi into integral of x is x square by 2, integral from 0 to 4, and this is going to be 2 square divided by 2 minus 0. So the volume of solid of revolution is nothing but, sorry, I made a mistake. Here I have to write x equal to 4. So 4 square divided by 2, that is 16 by 2, and it is nothing but 8 pi. So the volume of solid of revolution which we have generated by rotating this plane region around x-axis is 8 pi. Okay, so in this way, using disc method, we can obtain the volume of solid of revolution, or volume of solid generated by revolving a curve about axis of rotation. Here axis of rotation is x-axis. So if you are not comfortable with this explanation, you can just remember this formula. Volume of solid of revolution about x-axis is given by integral from 0 to 4 pi times y square dx, where y is the distance between axis of rotation and this graph. You can just remember this only. You can easily find out the radius of the disk generated by considering the distance between axis of revolution and this graph on the top. So the difference between these two is square root of x minus y equal to 0, that is under root x, and this is going to be the radius of the circular disc. So in this way we can easily compute the volume of solids of revolution. In upcoming lectures we will discuss some more problems of this type. So I hope you understand this. Thank you.